Hi everyone, in this lesson we'll be looking at two-way tables, which is another way to group items into overlapping categories, like how we did before with Venn diagrams. So there are many ways that this is helpful because this is much better than a Venn diagram in that a Venn diagram only shows one overlap, but this one can show more than one overlap. So for question 1, let's have a look. Households were surveyed at random to see whether or not they had dishwashers and clothes dryers. The results are in the table below. Okay, so we can see that there are two different ways we can express if you can have a clothes dryer or no clothes dryer, as well as two different ways to express whether there's a dishwasher or no dishwasher. And the intersection between these two values represents the condition that, let's say for example, for this number here, people who have a clothes dryer and a dishwasher. This one here represents people who have a clothes dryer and no dishwasher, and so forth. Okay, so we can look at many intersections between any of these conditions with any of these conditions here. So how many households were surveyed? Well, each of these represent a number of households, and if we add them all together, we do get the number 300. So there are 300 households divided up into many of these categories. Okay. So how many households had a clothes dryer and a dishwasher? If it's and, okay, that it involves a clothes dryer and a dishwasher, then we have to look at the intersection between these two, which is the number 75. How many households had neither of them? Neither meaning no dishwasher and no clothes dryer. That is number 68. Now for part D, what is the probability of selecting a household at random that has a dishwasher? So if we're looking just for a dishwasher, it doesn't matter if they have a clothes dryer or not. We can just exclude that. Who cares? So we're going to put, we're going to have a look at the number of people with a dishwasher, which is this one here. Okay. So if I add that up all together, what would that give me? 75 plus 49, that is 124. Now if we simply put that over 300, then our probability will change to 31 out of 75. Now part 2, a dishwasher and a dryer. So people with a dishwasher and a dryer represents 75. So we'll put that over 300, and I'm just going to write that is equal to 1/4, exactly. Part 3, a dishwasher or a clothes dryer, but not both. Okay, so if I just look at this, okay, number of people or households with a dishwasher, that includes these two, or a clothes dryer, that represents these two, okay, but not both. Okay, so if you don't want both, you don't want the one with both a clothes dryer and a dishwasher, so you remove this one. So the only numbers we look at are 49 and 108. 49 and 108 add up to become 157, and that is put over 300. Now what if we want at least one of them, meaning we want a dishwasher, okay, or a clothes dryer? Okay, so these are the people with just one of them, but these are the people with two of them. Okay, and that means at least one anyway. So in total, if I add these numbers together, 75 plus 49 plus 108 is 232. And we write that over 300 and simplify where possible, giving us 58 out of 75. Okay. Let's have a look at the next question. Question 2. People at a train station were asked whether they ate breakfast or lunch that day. Okay. So, how many people were surveyed? Let's add up all the numbers together. These represent the total number of people. And that would be 130. What percentage of people ate lunch? So people who ate lunch represent this column, so we have to add up these two numbers, whether or not they ate breakfast or not, we don't really mind. So if we add those two numbers together, we get a total of 89. But that's over 130, like that. But because it says write your answer as a percentage, we have to multiply this fraction here by 100. And that will basically get us around 68.5%. Now for part C, find the probability of picking a person at random who ate breakfast. So people who ate breakfast involve these two. Okay, it doesn't matter if they ate lunch or not. We just care about the fact that they ate breakfast. And that will be 61 out of 130. People who ate lunch belong to this column. In total, 35 plus 54 is 89. And we're going to put that at a 130. Breakfast but not lunch represents people in this row who ate breakfasts but did not eat lunch. Okay? Oh, sorry. It should be this one here. Okay? So it's 26 out of 130. And you can simplify that if you wanted to. A breakfast or lunch. So that means we can have breakfast only, or lunch, or both. So that involves anybody within this row who ate breakfast, and also anybody within this column here who ate lunch. So that represents all of these. So if we add them up all together, I believe we should get 115 out of 130. Yep. Part 5, breakfast and lunch. Well, that represents the intersection between this row and this column, and that's just 35. So 35 out of 130. Part 6, breakfast or lunch, but not both. So if we have breakfast or lunch, okay, so that represents this column and this row, okay, but not both. That means we exclude this one, but we include these two. Okay, so these are the people who ate breakfast or lunch, but not both, which means only breakfast. Oh, sorry, breakfast or lunch, but not both. Oh yeah, that's right. So it represents this and this. So these people only ate lunch, and these people only ate breakfast. So 54 plus 26 is going to become 80 out of 130. Part D. What is the probability of picking a person who has eaten lunch, given that the person ate breakfast? So if it says given that the person ate breakfast, we only select from that number of people. So from the number of people who ate breakfast, that involves this row here. If we total these two numbers up together, we do get a total of 61. So we're only going to write our number out of 61. And out of these people, picking a person who has eaten lunch out of the people who ate breakfast, that would be 35. So we're going to write 35 out of 61. What is the probability of picking a person who has not eaten lunch, given, okay, I'm just going to highlight that, given that the person did not eat breakfast? So we're now looking at this row here, and we're picking people who have not eaten lunch. So people who have not eaten lunch here are 15 out of the total here, which is 69. So the answer is going to be 15 out of 69. Yep. Let me just double check that. (54 plus 15), yep, 69, and we're picking a person who has not eaten lunch, which means this person, so it's 15 out of 69. Yep, it's going to be 5 on 23. Okay, so the answer in the book is wrong. Let's move on to the next question, which is question 7. So in this case, a group of retired people were surveyed on whether they exercise regularly. So this involves men and women, and whether they exercise or don't exercise. Okay, how many people were surveyed? Well, we have to add up all the numbers together, and that would be basically 320, right? So 320 is there. What percentage of people exercise? So we look at the column of people exercising, we add these two numbers together, 65 and 74 do add together to give you 139. We put that at a 320, but because it says find the percentage, we multiply this answer by 100. And we should get around to one decimal place, 43.4%. Part C, what is the probability of selecting a person at random who doesn't exercise regularly? So we don't care if they're male or female, so we add up these two numbers here. Okay, these include the males who don't exercise as well as the females who don't exercise. So that is 181 people out of 320. Part D says, of the women who were surveyed, what percentage exercise regularly? So given that condition that we're only looking at the number of women here, that includes this row, 74 and 75. So if we add them together, we're choosing people out of 149 people, and we're looking at only the people who exercise regularly, which includes the 74 people here. So if I put 74 on top and find out what this is as a percentage, which means multiply this by 100, we do get an answer of around 49.7% to one decimal place. Now for part E. If a man was selected randomly from this survey, what is the probability that he exercises regularly? So in this case, we're looking at the men only. Okay, so that belongs to just this row here. Okay, so if I add 65 and 106 together, I'm only looking at a total of 171 people. And we're just finding out the probability that he exercises regularly. So if he exercises regularly, okay, that involves 65 people out of that 171. And this time it's asking for a probability and not a percentage. So we're going to leave our answer as that. Okay, so 65 out of 171. Okay, I hope that helps you.